Hello world, Liu here, and today let's talk about 5 things I never knew about exceptions in Python until recently. So first up on this list, we have the try, except, else, finally block. So usually, when we first start learning try, except blocks, we learn only about try, except, and finally blocks. However, after the except block, we can actually add another else block. So let's try something like this. So try assert 1 is equals to 1, except print except block runs, else print else block runs, and finally print finally block runs. So let's run this and let's check what happens. So here we get else block runs and finally block runs. So what's happening here is that assert 1 is equals to 1 will not give us any problem, and the except block will not run because there's no exception that happens here. And next, the else block will run because the except block does not run. And that's why we have else block runs here. And afterwards, the finally block will always run whether or not there's an exception. And therefore, the finally block runs. So here, let's say if I assert 1 is equals to 2 and forcefully cause an exception, let's see what happens. So right now, except block runs and finally block runs. So what's happening here is that because of the statement assert 1 is equals to 2, an exception, or more specifically, an assertion error is thrown. So here, the except block will run, and because the except block runs, the else block will not run. And afterwards, the finally block will run regardless of whether an exception happens. And next, we have the assert statement with a message. So here, we usually use the assert statement as some sort of sanity check. So let's say x is equals to 4, and we want to assert that x is in fact an integer. So type of x is equals to integer. So let's print x. And here we are just going to print 4. So here, because x is actually an integer, our assert statement does not print anything. However, if I set x as a string, and if I run this, I will get an assertion error. So here, whatever appears on the right of assert is the condition, and if this condition is false, we will get an assertion error. However, one thing that we can consider is we can add an additional message for the assertion error. So x must be an integer. So once again, let's run this. And here we have it. So we have assertion error. And on the right of the assertion error, we have the message, x must be an integer. So this can be useful if you have many assertion errors and you want to make your debugging more clear. Number 3, we can actually ignore assert statements in Python. So here, let's print a bunch of stuff, apple, and next we assert 1 is equals to 2, and afterwards we print orange. So in our assert statement, we assert that 1 is equals to 2, but this is false, and therefore it will cause an assertion error. So let's run this, and we will get an assertion error. However, by running Python with the capital O flag, we can ignore all assert statements. We print apple, and we print orange. And here, our assert statement is being ignored. So this can be useful if you just want to run your code without having to deal with the many assert statements that you have in your code. And number 4, we have the exception hierarchy. So let's say we try to divide 1 by 0, and we'll get a 0 division error. So here we have 0 division error. So let's try to print the 0 division error dot bases. So bases is a list of its parent class. And here we have arithmetic error, which means that 0 division error is a child class of arithmetic error. And here, if we take arithmetic error and we try to find its bases, we will get exception. So exception here is usually the base exception class that we use to create our custom exceptions. So here, if we print exception dot bases, we will get base exception. And if we print base exception dot bases, we will get object, which is the highermost hierarchy out of all Python objects. And next, let's print exception dot subclasses, and let's see what happens here. And here we have arithmetic error, assertion error, attribute error, buffer error, and so on. So from this, we can actually somewhat see the hierarchy of exceptions in Python. However, also do note that there are some errors that are not exceptions. For example, our keyboard interrupt. So let's say while true, print apple. So this is an infinite loop, and if I run this, I'll just get apple over and over again. And if I Ctrl C keyboard interrupt, I will get this keyboard interrupt. So let's try to inspect keyboard interrupt. And if I run this, I will get base exception. So now we actually know that keyboard interrupt inherits from base exception rather than from exception itself. Which means that if we try to accept an exception, we might not be able to catch the keyboard interrupt. So here, let's write our while loop. Let's import time. So try and accept. So let's say exception as E, and let's print E. So let's just print apple and time.sleep for 0.5 seconds. So let's run this, and here we have apple, apple, apple. So next, I'm going to hit Ctrl C, and my keyboard interrupt will actually interrupt my program. And this is possible because keyboard interrupt is actually not an exception. In fact, it inherits from the base exception class. However, if I do this, base exception as E, and if I run this again, and right now I'm going to interrupt it, and now you can see that my keyboard interrupt is actually being caught by my accept block. So no matter how many times I Ctrl C, I will not be able to get out of this while loop. So I can only kill the entire terminal. So knowledge about the exception hierarchy can be useful if you want to have more specific knowledge about what kinds of exceptions that you can accept in your accept block. And number 5, we have raise exception 1 from exception 2. So here, if you're not familiar, the raise keyword will actually forcefully cause an exception to happen. So I'm going to raise exception, and if I print this, I'm going to get an exception. And if I pass in a message, hi, and if I run this again, I'm going to get exception hi. And similarly, I can do this for other kinds of exceptions too. So let's say I want to raise a 0 division error. And if I run this, I'll get a 0 division error. And here, if I want to raise a keyboard interrupt, I can do that. And I'll get a keyboard interrupt. However, we can actually take this one level up, and we can raise one exception from another exception. So let's say we want to raise keyboard interrupt from 0 division error for some reason. And if we run this, we will get this output. So we have 0 division error, and here the above output was the direct cause of the following exception. And here we have our keyboard interrupt high. So what this signifies is that at first we have a 0 division error somewhere in our code, and because of that, we are raising a keyboard interrupt because of our 0 division error. So this can be useful if you have many exceptions in your code base and you just want to make it extremely clear. So thanks for watching, and hopefully you have learned at least one new thing about Python exceptions today. See you in the next one.